Hello and welcome to the Preparation Week Unit 2 for the course Developing Web Apps with SAP UI5. My name is Michael. So, do you really understand JavaScript? That is the question for this unit. We will have a look at some very important concepts and typical pitfalls that you might stumble upon during this course. As you might already know, SAP UI5 is a toolkit implemented in JavaScript, so this knowledge will be very handy for you. And feel free to come back to this unit later when you work on the exercises of the course to fully understand the concepts. So, if you are fairly new to JavaScript, you might want to read one of the following free tutorials during the preparation week of this course, and we can recommend the JavaScript Garden and also the JavaScript tutorials linked here on the slide. And if you want to get in touch with other learners, you can also visit the discussion forum or so during this preparation week. So this unit is a little bit different than a typical unit of our openSAP course. You should pause this video right after I have explained the slide and then go straight to the self-test questions of this unit. There you can check your JavaScript knowledge with 15 challenging questions. Don't worry if you can answer them all. They are intended to test your knowledge on JavaScript. Each question contains a link to one of the tutorials shown before that explains the concepts in more detail. Read a bit about the JavaScript concepts and try again. Once you have most of the self-test questions answered correctly, continue with this video where I explain more details. Then you will really understand JavaScript and are more than ready to start this course. So please press pause now and do the self-test questions. Alright, welcome back. So let's do a quick recap on what we have seen in the self-test questions, and let's start with JavaScript and browsers. So JavaScript is a scripting language that is supported by any modern web browser and allows developers to enrich web pages with additional logic. This use case, client-side scripting, is what we focus on during this course to create web apps. Our JavaScript code is interpreted at runtime when the user calls the page. Each browser, however, has its own implementation of the JavaScript engine that is highly optimized for processing JavaScript code. There's also an HTML and CSS engine, and mobile devices are typically a little bit slower than desktop PCs. So JavaScript is properly known as ECMAScript, and ECMAScript is the formal specification of the JavaScript language. Browsers implement this specification, but there are slight variations in the range of supported features and implementation details. Frameworks, such as SAP UI5, usually cope with this, so you don't need to worry too much about it. Client-side JavaScript is also executed in a sandbox, so you cannot really access the local system of the user from the web page. And it's limited to the capabilities of the browser. However, if you want to overcome such limitations, you can package a JavaScript application as a native application or using web workers. In this course, we will focus on traditional approach of executing a web page in a browser. So, when we talk about creating web apps, which is what we do, then we will do client-side scripting with JavaScript. All the presentation logic, for example, formatting and re-rendering the UI elements, is done on our client side, inside the browser. Only the resources, for example, the HTML file, code, and additional data, are loaded from the web server. The code is then processed on the client to create DOM elements on the screen. Note that JavaScript is really single-threaded, so there's only one JavaScript thread per window. Other activities like re-rendering or downloading resources may be managed by several threads, but they can also block the user. So we will see later how to avoid these blocking issues. The data we want to present in our application is usually loaded from a remote server using XHR requests, which is short for XML HTTP requests. And it's a technique to call data from a remote system. So most often these services are OData or REST-based, And on the back end, they usually return a lightweight JSON or XML structure. And this one can then be formatted and displayed on the screen. So in contrast to server-side application, most logic is actually executed decentrally on the client. So this is the main aspect of client-side scripting. And JavaScript has its linguistic inheritance in several languages. So it's kind of a mixture of different technologies. All that together, it forms a very dynamic, flexible, and powerful development tool. And it's a perfect foundation for SAP UI5 because it's really flexible and capable to do web apps. We have parts of the syntax of Java, for example, the dot notation, as well as the powerful regular expressions from Perl combined. The first-class functions, which you will see later in this unit, they come from a functional programming language called Scheme, and the prototypical inheritance is from Self. Prototypical inheritance means that objects instances reference their base object. If the base object changes, all the object instances are affected by this change. And by combining all these different concepts from different languages, it allows you to write very flexible tools and applications. But for the same reason, it's also hard to master. Okay, let's start with something easy. So we want to have a look at some type examples and the implicit conversion system that is part of JavaScript. So JavaScript as a language only knows 6 base types, which is number, string, boolean, object, null, and undefined. And it's a weakly typed language and does implicit type conversions at runtime. Here are some examples on the right, but I want to show you this in real life. So let's open a browser. And I go to the developer tools by pressing F12. And here's a console where I can execute JavaScript. And if I, for example, put in a string here, 5, and then multiply it with another string, 2, then what internally happens is it converts those 2 strings to numbers and does an addition. So the result is 10. Then if I want to compare 2 things, for example, I want to compare 1 for true, then it's actually true because it's doing an implicit conversion here as well. Only if I do 3 equal signs, then it will consider the type as well, and in this case it's false. So it's really important to think about these typing issues in the beginning, otherwise you will have issues in your code. And what really helps with it is this Hungarian notation. So for example, I put an I for integer in front of my variable name and an S for string. Okay, let's have a look at some more details on the object. And an object is an unordered collection of name-value pairs. The names are called properties, and the values can be of any type. So if it's a function as a value, then it becomes an object method. And objects also may have a constructor function, then they define a context. So, and then you can access the member variables and methods with the this pointer. And if I give you an example in the console, you will quickly see how this works. So I define a variable named car, and I give it a type, which is then a variable. So I can say, for example, compact car, and I give it also a method called honk, which is a function. Then inside the function, I can do, for example, an alert. And then by using the this pointer, I can display the type here and say, for example, meep. And then I only have to make sure that I use the right brackets and everything to finish the structure here. This one worked. And then I can use my car object and call the honk method on it, for example. So now you will see it displays company car meep because I accessed the member and a static text. So in contrast to languages like Java or C++, inheritance of objects is not based on classes but on prototypes. And that also means that properties and methods can be added and deleted at runtime. This is a very powerful construct, but also dangerous at execution. So in my car example here, I can add a new property, for example color, and I give it a blue color value. So, but I can also remove it again at runtime. So if I call delete car.color, then it's gone again. And this one happens completely at runtime, which is not possible in other languages. Right, enough about objects. Let's take a look at one other strong feature of JavaScript, and that's the functions. So I said already, in JavaScript, functions are first-class objects. But what does that mean? So it means that they can be created dynamically and assigned to variables as well. And this is a powerful mechanism to structure your code. On the right side, you can see typical patterns. And on top of that, you can also pass functions as parameters to other functions. And this is the basis for asynchronous callbacks or eventing functions that we use a lot in SAP UI5 and also in typical JavaScript projects. One more thing about functions is also that JavaScript does not really have a function scope, does only have a function scope, but no block scope. So this means that each function creates its own local scope, where all the declared variables are visible, independent of the nesting structure inside the function. And when nesting two functions, the inner function has access to all the variables of the outer functions and builds a closure. Okay. A really important concept that we will use a lot during this course is asynchronous processing. And what happens if you do synchronous processing is often what you can see on the right side here. The browser simply gets unresponsive and the user cannot do any interactions anymore. And that's why you always want to load resources and do computational intensive tasks in an asynchronous way. And there's some helper functions in JavaScript and also in SAP UI5 that you can use for this. So for example, you can load modules using the AMD, the asynchronous module definition syntax. And this is integrated already in SAP UI5, or there's also a module called require.js that does the same. Or you could decide to split up long-running tasks using a timeout function, but this is not very often used. What is more common is to use callback functions, event listeners, promises, and some kinds of framework hooks that you can plug in additional logic, and then they are called by the framework at the right point in time. Okay. What you also see quite often in jQuery and also in SAP UI5 is this method chaining, or it's also called cascading. And if a function returns a reference to its own context, then you can call another function right afterwards, as you can see here in this example. So I only fetch this DOM reference to my button here once, and then I execute several logical functions. For example, I change the text, do some CSS manipulation, or even call another function here. And it's a nice time saver because it saves you writing code, but it's also really hard to debug because you cannot really set breakpoints in this one. And one of the hardest parts in JavaScript, but it's also really important to understand, are the closures. So as I said before, closure is created when nesting two functions. The nested function inherits the scope, and with that all the variables defined in the parent function. You can see this also on the right side in this very simple example. So the inner function, when it is called, can access this parameter here, the attributes, and everything that is defined in the inner function. And you can think of it as a live thing that stores the context of the function. And you will discover this sometimes during the course. And it might also make sense to read something more about closures in general. Then also one really important thing is the this pointer, or the this definition. And if we go back to our browser example, and I type this here, then it's also always a reference to the global window object. And here, some basic functionality of JavaScript is defined, for example, the math.round function or different other things. But this object is also very dangerous because it's actually not read-only. You can also write stuff in here. And the this construct always depends on the current scope. So going back to my presentation, in the global scope, as we have just seen, it's the window object. But in an object scope, this instance is actually the current context, and you can access methods and properties from it. And in the function scope, it really depends. So you need to take care of it, actually. We can see this on the right side. If we have a callback function that is simply executed, then the this pointer is actually the global object because the reference is lost here. And by using a helper construct, for example, building a closure, we can save the context. For example, here I define a variable named that. And in the inner function, that is still the same as this. So I can call properties and methods again using the that pointer. Or I decide to use the bind construct, which is standard in JavaScript, and I bind the this pointer for this function call. And when I later call this function, I can just simply use the this pointer again. And it's not the global window object, but what I have passed into this bind function. All right, that's it for this unit. Do you really understand JavaScript? Now you have seen the most important concepts and pitfalls when using JavaScript. If you are fairly new to programming, you might need a bit to get familiar with all the concepts. But don't worry too much, a good JavaScript developer isn't born in a day. You will get a lot of practical experience throughout this course, and you can always come back here to this unit to learn more about the concepts. See you in next unit. Bye-bye.